In the book that will get a little bit harder, it might say the sum of how many terms will it take to get bigger than 1,000. So then you're going to go, well, the sum will be 1,000, and I want to find n. How many will it take? So you're going to have n times 2. 2 times 3 plus 50 minus n. Yeah, so...
Is it n minus 50 or 50 minus n?
Good call. 50 minus 1 is the n. N is our unknown.
Yeah.
Right. So make sure you do a broad spread of all of those, and that's arithmetic sequence is done. Okay. Do you want to do a couple, or we go straight into geometric?
So it's showing again.
Yeah, geometric.
Yeah.
Give me a pattern. It's geometric.
2,
2.
4,
8,
6.
Sorry for that.
16, 32.
So geometric is a constant multiplier. So here, term n equals a r to the n minus 1. A is, again, first number, because a is the first number in the alphabet. R, what does R stand for?
Ratio.
Ratio. There's a common ratio.
2.
What's the ratio of 4 and 2? 2. What's the ratio? What's 8 divided by 4? 68. So R's the ratio. So term 10 would be 2 times 2 to the 10 minus 1. And then your next line would be the answer. Try to actually apply the rule verbatim. Not that it's a big deal, but if you put the 9 in there, you haven't substrate into the proof. I'd rather you put the 10 minus 1 there and then just use your calculator and put the 9 there. And then we've got the sum. A RBN minus 1 on sum of the first n is enough. And what's then coming up that we don't
Infinite.
Yes.
Infinite elements.
This is like
We'll just keep that between ourselves.
So we don't do that again?
Yes.
Oh, we do?
Oh, yes, we do.
But you're waiting until they're done.
Yeah. You're good with secrets.
It's like, what?
Okay, so term n, the sum of n, and then sum to infinity. And if I wanted a rule for r, would be?
Tn plus 1 over Tn.
Yeah, it's not. So you read in the book.
What? You gave it to us to do that. I'm reading
That's what I'm
through
doing. I'm looking at my notes. We're going to look for what's special about what does r have to be for this to happen?
Less than 1.
Less than.
I read your book.
Also, I just let your memory was good. What if I went? Oh, I've just done Gabe's geometric sequence.
I know what that one
So if I said fill in the box, although you can do it using your head, I'd be liking you to what? Find the pattern. Yeah. So term n equals a RBN minus 1.
So
So you're going to get
So
some
in the 2
simultaneous equations.
and
So,
8.
so you know what A is,
Yeah.
but you don't really know what R is, but you know what term 1 is and term 3 is and term 5 is, so you're going to get some simultaneous equations to find your R.
Yeah.
Do you want to do that?
Yeah. So there's a couple of them in the textbook, make sure you do them.
Can you do that one?
This one? Okay, so term n. So term 1, n is going to be 1, so I'm going to 2 equals, a is 2, so 2, r, what's n?
1 take, so it'll be 1.
So does that get us anywhere? What's 1 minus 1?
0.
0. What's r to the 0?
0, 1.
1. So 2 equals 2. Oh my gosh, that's a good, solid dead end, isn't it?
Yes.
Term 3, a equals 2 r to the 3 minus 1, and 32 equals 2 r to the 5 minus 1. They get somewhere, don't
They do.
they? So let's just go 2r squared equals a, and 2r4 equals.
Because how do you divide 8 by 2 and then square root 4?
Okay. Oh, yeah, there you go. Straight in. You don't even need simultaneous equations.
But it'll be a lot harder at this than.
No. I thought we might have needed simultaneous equations, but we don't. We don't have two unknowns, do we? Whoa.
Did we do it wrong?
Yeah, I didn't make it hard enough.
I hope you have that realization after the test.
I
Oh.
didn't make it hard enough.
So if you take away the 2, then you would.
Like if you
Yeah.
put blocks in front of
So what if I said-
Just take away the.
Okay, so
Yeah, there we go.
This is term 1,
Oh, yeah.
and then that's term 2. You're going to have two unknowns.
Yes, and then choose simultaneous.
Yeah. All right, what was I thinking? Because we only didn't know R, did we? So we didn't need two relations for all. I want to do that because there's the book shows you a wrong technique that I've highlighted in your workbook, but I want you to. Let's just go back to here. Let's go back to here and do this question that it should then. So term 2, so 2 equals a r to the 2 minus 1, and 2, that's term 4, so a equals a r to the 4 minus 1. So we're going to get 2 equals a r, plus equals just there, and a equals a r cubed. Happy with that?
Yeah.
The book tells you to divide
those two equations.
those two equations. Have we ever used divide
No.
in rules? No. So what we don't want to do is introduce something that works in specific situations. So it does work, you get the right answer, but it's a bad technique because you might be tricked into thinking that you can divide anything.
A equals R on 2. No.
So this one here, A equals R on
No.
2 on R.
Yeah.
Thanks, Claire. A equals A and A. We're going to use the substitution method. So 2 on R equals A on R cubed. If the R cubed up here, R cubed on R equals A on 2. R squared equals 4.
2. Root 4.
2. Also minus 2.
Plus or minus 2. Let's just, looking at the pattern, has to be 2 this way.
Yes.
So can you, and then once you've got that,
Sub
A
that.
is easy, isn't it?
Yeah.
So please use the substitution technique when you're doing this and don't use the division
Wait,
method.
so you can just swap them, the 2 and the r cubed.
Yeah. You're times
I'm
equal 1 by
multiplying
R.
both sides by. So I'm using just valid algebra techniques here to solve for R. Getting R to the other side to get R cubed on R and dividing by 2.
Oh, yeah.
I just didn't put it in. So I'm dividing by 2 to both sides
Yeah.
to get that. That cancels to get an R squared and I'll just pull out.
Do you
So we would have to show that working though.
It's math C. what I did with so that I want you to show off your algebraic skills, your hard algebraic skills, not what we would do in Web 10. So you can skip stuff, but there's stuff there that's
Skip the racks.
mathsy stuff that I don't want you to skip because otherwise it looks like you've used your calculator. Yeah. But yeah, that is exactly how it will be in the exam, and I go, awesome job, big tick. Might be a bit neater.
What? The working or the tick?
Both. Do you care how messy the tick is?
No, it's a tick.
As long as it's tick.
Okay, we good?
It actually has to be 3 centimeters at a 45 degree angle.
So I hope that worked.
Done?
Did yours work?
I don't. I thought it didn't, but I think it did. See, that's too long. See, even that's 14 minutes.